Welcome to another episode of Jensen Does Chemistry Stuff. Yay! What we're going to do right now is some problems involving Avogadro's number and the mole. If you haven't watched the video about what a mole is and you don't really know what a mole is, please pause this video, go watch that video, and then come back. All right, question 1. How many moles of water does 6.02 times 10 to the 23rd molecules represent? Well, if you listen to my advice and watch the video about what a mole is, you learned that a mole is 6.02 times 10 to the 23rd anythings. Molecules, formula units, atoms, chickens, whatever. A mole is simply a unit that represents this many of something. So how many moles of water is this many molecules? Well, that is literally the definition of 1 mole of H2O. Question 2. Convert 3.01 times 10 to the 23rd molecules of C2H6 to moles. This is where we're going to dig back into our skills in using dimensional analysis. Step 1 in dimensional analysis is write down what you have. When you read this problem, it tells you you have 3.01 times 10 to the 23rd molecules of C2H6. Wow, it is a pain to write out molecules C2H6, but you gotta do it. You really have to write down the unit and the chemical. Because as we get deeper into stoichiometry, we're going to be finding much bigger equations where you're going to have more than one chemical that you're dealing with. So it's critical to write down what exactly you're doing. Not only that, but this right here is what leads you to the next step in solving the problem. So it's very important to write down your units. All right. So in the end, what do we want? We want moles. I'm going to write it way over here. Moles of what? Of C2H6. All right, so next step. We have molecules of C2H6. We want moles, so we have to get rid of molecules of C2H6. The way to do that is you put it right here. Now, you have to put something in here that is true. So, anytime you see molecules, formula units, atoms, you need to go straight to thinking about Avogadro's number. So that is 6.02 times 10 to the 23rd molecules of C2H6 is 1 mole. It is totally legal and legitimate to write this down because this 1 mole is equal to this 6.02 times 10 to the 23rd molecules. Therefore, this is the same thing as just plugging times 1 into there because anything divided by itself is 1. That same logic and reasoning is why you are able to cancel units because molecules of C2H6 divided by molecules of C2H6 is something divided by itself. And so it's totally legal to cancel out units. Now we're left with 3.01 times 10 to the 23rd moles times 1 moles divided by 6.02 times 10 to the 23rd. All right, 3.01 divided by 6.02 is equal to 0.5. 10 to the 23rd divided by 10 to the 23rd, well, that's equal to 1. So times 1, which would just be 0.5 moles. These cancel out of C2H6. Sharper pencil. All right. Next question. How many moles How many moles of glucose does 1.2 times 10 to the 23rd molecules represent? So what do we have? 1.2 times 10 to the 24th molecules of glucose. I know it's a pain to write all that. Just do it. Do it. And what do we want? We want moles of glucose. So in the end, we're going to have moles. I'm going to write it way over here. Moles of glucose. All right, step 1. Get rid of this. All right, so anytime you see molecules, atoms, or formula units, Avogadro's number. Alrighty then, now you just got to put something that's true in there. Well, 6.02 times 10 to the 23rd molecules is 1 mole of glucose. Which is great, because that's what I want. Cancel. That times 1 is 1.2 times 10 to the 24th divided by 6.02 times 10 to the 23rd. So 1.2 divided by 6.02 is 0.199. And 10 to the 24th divided by 10 to the 23rd is, that's how you do that. I will be giving you, next class, I'll be giving you a go-by that shows you how to divide numbers with exponent scientific notation and how to multiply it. But this is how you do it. So 24 minus 23 is 1, so it's 1.99 times 10, which is equal to 1.99 moles. Which is great because the scientific notation police would have had a real problem with us having the decimal here. We'd have to move it there anyway, but since we multiplied times 10, that's what it makes us do. Yay! Whoop. All right, next question. How many moles of calcium chloride does 2.41 times 10 to the 24th formula units represent? So we want to know moles, and we have formula units. So 2.41 times 10 to the 24th formula units of calcium chloride. And we want moles. Of calcium chloride. So once we have established what we have and what we want, our next step is get rid of these units that we have, because that's not what we want in the end. So formula units of CaCl2. Now, formula units, we think Avogadro's number, so 6.02 times 10 to the 23rd formula units of calcium chloride is 1 mole of calcium chloride. So now we can cancel out our units, and we have 2.41 times 10 to the 24 times 1 is just itself, and we have moles of calcium divided by 6.02 times 10 to the 23rd. All right, so we have to divide this. Again, I'm going to give you a paper that's going to show you how to divide numbers that are in scientific notation. But what you do is first you take the coefficient and divide those. So 2.41 divided by 6.02. And that gives us 0.4. And then 10 to the 24 divided by 10 to the 23. And 24 minus 23 is 1, so it's 0.4 times 10, which is equal to 4. All right, so that gives us 4 moles of calcium chloride. How many atoms does 2 moles of helium represent? So we have 2 moles of helium. 1 mole of helium is 6.02 times 10 to the 23rd atoms of helium. So it's just 2, we cancel out our units. 2 times 6.02 times 10 to the 23rd. You just go 2 times the coefficient and then tack on this. So 6 times 2 is 12.04 times 10 to the 23rd atoms of helium. However, the scientific notation police are going to come because your decimal has to be right here. It has to be after the first non-zero number. And so we're going to move the decimal over to the left 1 spot to be 1.204 times 10. Now, if we move the decimal over, then we have to raise up the exponent by 1. Because if you multiply 1.2 times 10, that gives us our 12. It gives us back to where we were. And so we have to add that 10 on to our exponent. We'll spend some time kind of talking about how that works, but for now I want to show you a little trick that we came up with. And that is, if you move the decimal to the left, you lift the exponent. You lift it up 1. You raise it up by however many places you move the decimal. If you move the decimal 2 places, then you raise it by 2. But you lift the exponent if you move the decimal to the left. If you move the decimal to the right, you reduce the exponent. So the exponent goes down by however many decimal places you move the decimal to the right. So if you move it to the right 1, then you add 1 to this. You take 1 away, you reduce. To the right, you reduce. So it would go down to 22. If you moved it 2, it would go down to 21. So the decimal moves to the left, you lift up this number. If you move the decimal to the right, you reduce this number. Okay, let's do the next question. How many sodium ions are in 3 moles of sodium chloride? So we have 3 moles of sodium chloride. And we want to know sodium ions. All right, so what is a sodium ion? Just to remind you, sodium chloride is made when a sodium atom gives an electron to a chlorine atom. It gives it away, giving the chlorine atom a negative charge and the sodium atom a positive charge. These 2 ions are then attracted to each other, and that attraction is an ionic bond. So this right here is a molecule of sodium chloride. This is an ion of sodium. So just keep that clear. Now let's go back to the question. The question says, how many sodium ions are in 3 moles of sodium chloride? So 3 moles of sodium chloride is what we have. So we have to get rid of moles of sodium chloride. So 1 mole of sodium chloride is 6.02 times 10 to the 23rd formula units, or molecules, of sodium chloride. All right, now that gets rid of our moles of sodium chloride, but we want sodium ions. So let's get rid of formula units of NaCl. 1 formula unit of NaCl has how many sodium ions are in 1 NaCl? Well, there's only 1. If it was Na2Cl, then it would be 2 sodium ions, but it's not. There's just 1 sodium ion. So 1 sodium ion in every 1 of these. Whoops, this needs to be like over here. All right, let's do that. There we go. So 3 times 6.02. So 6 times 3 is 18. So it's 18.06 times 10. So 3 times 6.02 is 18.06 times 10 to the 23rd sodium ions. And it's just divided by 1. It's just divided by 1, so we don't worry about that. And we cancel out our formula units, and we end up with sodium ions. So we have 18.06 times 10 to the 23rd sodium ions, which is correct. However, the scientific notation police are going to come and say, move that decimal. So we're moving it to the left. 1.806 times 10 to the, and if we move it to the left, we lift the exponent. Left we lift, right we reduce. All right, I'm going to skip number 7. You do that one yourself. Number 8, how many total atoms are in 1 mole of water? So we have 1 mole H2O. So 1 mole of H2O, because we have to cancel these out, is 6.02 times 10 to the 23rd molecules of H2O. Okay, but this is not asking for molecules of H2O, so we have to get rid of molecules of H2O. So 1 molecule of H2O, what does it actually want? It wants atoms. So how many atoms are in 1 molecule of H2O? Well, there's 2 H's and an O, so that looks like 3 atoms to me. So there are 3 atoms in 1 molecule of H2O. So 6.02 times 10 to the 23rd times 3 divided by 1. We cancel, 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 cancel. We end up with atoms. So 6.02 times 10 to the 23rd times 3 is 18.06 times 10 to the 23rd. And you do the exact same thing because it's the exact same answer here. So it'll be 1.8 times 10 to the 24th atoms in 1 mole of water. All right, thank you for watching.